Hi, boys and girls. My name's Mr. Cooper, and I'll be teaching science this year. I hope that if you don't like science, I hope that you'll love it by the end of the year. I don't know about you, but when I went to school, I don't think I even touched anything or did anything until I was in high school, but that'll change here. You will be working hard for me, doing a lot of writing. We don't have a book, so your book is going to be your notebook. But I try to have a lot of activities in there too. So with that, let's go ahead and get started. First of all, you're going to need a few things today. So you'll need your notebook. You'll need a sheet that was in the packet I gave at open house called Is It a Model? You will need What is a Model? You will need your glue stick. You will need your highlighter. And you'll need a pencil. Post-its would be nice too, so we can label stuff, all right? And with that, let's get going. Remember, you can pause this at any time. Usually when I'm in class, I watch students and watch how fast they're copying. One of the neat advantages of doing things on film here is you can just stop it whenever you want, so feel free to do that. All right? Well, let's get started. So, one of the first things I'd like you to do is I would like you to number your entire book from 1 to the end, all right? Remember to number each side of the page like this. See how this is number 1? And then here's number 2 over here. Just do that through the whole book. So that should probably take you, I'm guessing, 10, 15 minutes. Why don't you go ahead and pause it, and then when you come back, we'll be ready to go, all right? All right. Well, welcome back. So get ready to do a little writing today. First of all, I want to set a few ground rules down. And the first one is that I would like all writing in this book to be done in pencil. And the reason I do this goes back to, well, I used to be a fisheries biologist for a few years. And one of the things I learned was pencil never smears when it gets wet like ink does. So even if I dropped the book in the water, I could still read it. And frequently when you're in class in science, things spill and you name it. So make sure to do that. I do not want it in pen. And of course, it'd be nice to know, what is science? I had a hard time coming up with, well, what is science? That's what we're studying. And this is my best description. And it's our attempt to understand the world around us, right? You don't have to be some guy that looks like Albert Einstein with all the crazy hair and everything else. In fact, I think even babies make the perfect scientist, if you ask me. And I'll explain why in a minute. It says, we will frequently be using our 5 senses in science, which include, to make these observations, smell, sight, touch, hearing, and taste. You want to be careful about the taste one when you're in my lab doing science. That could be hazardous to your health. I mean, think about a baby. They're always like putting stuff in front of them, they'll grab something, and they might smell it. They'll look it all over, they'll turn it around, look at it. Of course, they'll touch it, and they'll touch it in all their fingers. They'll stick it in their mouth and see what it feels like. And of course, they love things that make noise. And then, obviously, they're tasting it. It always makes its way into their mouth at some point. All right, so you might be wondering, what's the purpose of notebooks? Well, like I mentioned earlier, first of all, we don't have a book, which I kind of like. So you'll be writing everything down in a notebook. I like notebooks because I get to write my own book. But anyway, it acts as show-me's for science. It kind of lets me know how you're thinking. Feel free to jot little things off in the margin if you have questions or things you want to look up. I do this all the time. And the second one is it lets me take ownership for my learning and allows me to ask questions. So it's up to you to write things down. I'm not going to write everything off for you. It's up to you to write things down as we go. Okay, and again, if you have questions, that you want to ask, or maybe stuff for you to look at, feel free to write those down in your notebook. And the other thing is acts as a reference. In science, when I have notebooks, even as a fisheries biologist, I'd go back and I had field notes of things. I can always go back and use references. I mean, that's the real world. And by the way, in a practical sense, I also let you use your notebooks for any of the tests or quizzes I give you. So there's four main areas of study this year that we'll be covering. One is engineering, which is what we're going to start with. Two is astronomy. Three is matter and energy and ecosystems. And last, properties of matter. Now, I told you I like science, so we'll be doing lots of other little projects too, but those are the main four areas that we're responsible for in fifth grade. By the way, notice I've already done a little tab here. I hot dogged one of those sheets like that. I hot dogged it, and I wrote notebooks and science, right? So if I want to figure out about this, I would just go back to this page. Turn to the next page. So, as I said, we're going to start with engineering, and our four main projects, we'll do two a semester, is we're going to start off with a tower. I'll talk about that today. You're going to make a zip line, a solar oven, and rockets. All right? So what is engineering? Well, before I talk about engineering, I don't know about you, but I kind of got confused when what's the difference between a scientist and an engineer? I kind of see them the same, but they are different. So for instance, a scientist tries to answer a question, okay? An engineer is a little bit different. They develop solutions to a problem. So they've got a problem, just like a scientist did, but they normally come up with a solution to solve things for human needs, design something to solve a problem for human needs. Many times models are used for a number of reasons. Probably the most important is cost and practicality. We'll be building models throughout the year, and we're going to talk more about that later. Examples of engineering. You know what? They can be very extravagant, like making a drawbridge or something else, or maybe even designing a rocket to Mars. But there's simpler things too. In class, if you've ever been in my class before, you'll notice I have a refrigeration unit in here. I had to make all kinds of problems with the tank. One was the filter they gave me wasn't even good enough to house 100 fish, and I'm upwards of usually between 900 and 1,000 fish each year that we release for the second graders, and so I had to engineer a better filter system to handle the big biomass. I also had to in that filter system I had something that circulated the water, and I had to come up with something that was quiet. And then I had to worry about the refrigeration unit because I didn't want to make noise and distract students, so I had to figure out a way to insulate this thing so the refrigeration unit wasn't going all the time. So those are just a few of the problems I had to solve. Plus, I don't know if I told you, I even had problems with fish going down my filter, so I had to figure out a way to deter them from going down my filter because, salmonos want to swim upstream, so whatever the water's going, they want to go back the other direction. Think about things in your house or things you've done where you've had a problem and solved it by making something or devising something. I'd be shocked if you hadn't done this. All right. So let's define engineering a little bit more. First of all, engineering is identifying and defining a problem to solve. What exactly is the problem you're wanting to take care of? Oh, I have some erosion over there. What kind of structures could I build to stop the erosion? Or vegetation, maybe something like that. You're going to want to generate possibilities. What are some different ways I could solve that problem? Whatever. In fact, I know this sounds weird, but I'm doing this with some Windows right now, working on some engineering on support, and I've come up with a number of different ways to do this. You'll test solutions and collect data. So you'll test them out. You'll basically try it, usually in the form of models, and see how it works. And write down what you observed. And then you'll analyze and interpret results. Oh, on these different models, I think this one works best because, that sort of thing. So that's what we do. And you'll find yourself jumping all over the place. I wrote these in numerical form, but you could find yourself jumping back and forth all over the place. It's important that you understand some vocabulary so you understand what I'm saying to you. The first thing is problem, and a problem in science, and probably math too for that matter, is a situation that requires a solution. You're going to be expected to come up with an engineering solution to something. You're going to be using lots of models, so you need to know what a model is. And a model is a representation of the real thing. A representation. It doesn't have to be a physical model either. We'll talk more about that later. And normally when you're making a model, you're making a prototype. A prototype is like a small version of whatever it is, sometimes even a larger version, but usually a smaller version. If you've ever seen people get patents, usually what they do is they build a very small model of whatever it is they're trying to get a patent for. And of course, a solution is a structure or process that solves the problem we started to begin with. A couple other things that you're going to have to deal with: constraints, limitations to possible solutions. Normally, engineers have to deal with money and time. Or in your case, on your first project, it's going to be time and also supplies that I'll let you use. And of course, the other thing is criteria. I need to tell you, what does it mean to be successful? If you're an engineer and you've got the problem, what am I looking for that your project is actually successful? All right? So, next, you've got a sheet here. Is it a model? And I want you to glue this in place right below that. And all you need to do is touch the glue 1, 2, 3, 4 on the back. Can you see how I did that? That's all you have to do. Now, thinking about what we've said with a model, I would like you to just check these off. It says below are listed things that students might do in a science class. Check off the things that are examples of using a model. So I want you to check all those things off. Think about it. This is kind of backwards to me. If I were you, I'd explain. It says explain your thinking. How do you decide whether something is a model? So you might want to, for me, I would want to think of what I think a model is to begin with. Maybe you'll formulate that idea after you look at all these. So go ahead and fill that out, and when you come back, we'll go ahead and go through that. So go ahead and I'm going to actually make this the end of the video, and then we're going to go to a second video, all right? And then we'll pick it up from there.